What is fluid? Anything that has tendency to flow can be referred as a fluid. The fluid can be anything gas or a liquid. It is a misconception that only liquids can be termed as fluids. Even air is an example of fluid because air can flow. The friction created by these fluids are dependent on the viscosity of them. Viscosity is indeed dependent on the intramolecular forces of the particular fluid. A fluid having strong intermolecular forces will have high viscosity and vice versa. What is fluid friction? As discussed in the above section, fluid friction is that friction which an object experiences while it is moving between the layers of fluid. The friction occurs mainly due to the viscosity of the fluid. The viscosity is that property of the fluid which tells us how smoothly will the liquid move freely. The shear stresses are weak in a liquid having high viscosity and vice versa. Let us discuss more about fluid friction in further sections of this article. How to find fluid friction of an object. The fluid friction of an object is the opposing force experienced by the object when it is moving inside a fluid. The formula to calculate the force exerted by fluid friction on the object is given in the section below. F equals *do/dy, where F is the frictional force. A is the cross-section of the object subjected under friction. U is the relative velocity between the layer of fluid and the surface of the object. Y is the distance between the fluid layer in contact and the bottom-most layer. How does fluid friction affect objects? Fluid friction mainly reduces the kinetic energy of the objects moving between the layers of fluid. The shear action of friction will slow down the objects, and sometimes they can even wear off the material layer on the object. The frictional force exerted by fluids is called as the drag force. The word drag force is commonly heard in the aviation industry. To minimize the effects of drag force, we make the aircraft's aerodynamic that enables the aircrafts to fly with minimum resistance. This way a lot of fuel can be saved. What type of fluid friction acts on an object? Fluid friction is itself a type of friction. The type of force that fluid friction exerts on the object is shearing force. The shearing force is that force which acts parallel to the surface of the object on which it is acting. The shear force acts on the topmost layer of the surface of the object. If possible, the shearing action can even wear off the material on the surface of the object. How does fluid friction depend on the speed of an object? The speed of an object directly affects the amount of friction acting on the object. We have already discussed this in the above section about the formula on how to calculate the fluid friction force. From the formula, we can see that the velocity gradient is directly proportional to the frictional force acting on the object. That means greater the velocity of the object, greater will be the friction force, and vice versa. What is a fluid friction acting on an object moving through the air? When we experience fluid friction while moving in air, for example aeroplanes were swinging a bat or swinging arms etc., then the resulting fluid friction is called drag. The drag force is that opposing force that acts in the opposite direction to object's displacement inside the fluid. The drag force is not desirable for aircrafts as it slows them down, but the drag is very important for parachutes as drag force, buoyant force, is responsible for a safe landing of the diver or vehicle that uses the parachute. What will be the fluid friction when objects move with a special shape? When objects with special shapes move inside the fluid, the amount of friction acting on them will be different. This is so because fluids have a tendency to flow around round objects and it opposes the objects with a flat surface. The objects having streamline shapes will move in a very smooth manner. This is because the fluid will flow smoothly around the edges of the body rather than pushing it against the motion of the object. This is why fishes have streamlined body, which enables them to move inside the water at a lesser expense of energy. What is it called when the force of fluid friction on a falling object is equal to the force of gravity? When an object falls under the influence of gravity, it keeps on increasing its velocity not only up to a certain extent. This extent is called as the terminal velocity. The terminal velocity is that maximum constant velocity that an object can attain while falling freely. The terminal velocity depends on the viscosity of the fluid inside which the object is falling. No object can move with a greater velocity than terminal velocity without having any external influence. What is fluid friction called, as why do we streamline objects? We streamline objects due to one reason: reduce the effective drag force on the object. If the drag force is higher, then the amount of energy needed to overcome the drag is higher. By streamlining in the shape of the object, we can easily minimize the effective drag, as the drag force acting on the object will reduce. This is because the molecules will flow around the edges of the streamlined shape rather than opposing the motion of the object. Hence, we streamline the shape of the objects to reduce the effective drag. Examples of fluid friction. The examples of fluid friction are given in the list below. Swinging a bat? When we swing a bat, the bat experiences a resistance due to drag. This drag comes from the air molecules which are striking on the surface of the bat. In vacuum, the bat would not have experienced this resistance. Due to the presence of fluid, which in this case is air, the bat experiences drag. Peeping out of a moving vehicle? When the vehicle is moving and we peep out from the window, we experience a force pushing back. This force comes from the air molecules striking on our face. The relative velocity of the air in our face is more due to the movement of vehicle, hence we feel a resistive force. We would not feel this force if the vehicle is stationary, because the relative velocity between air and face would be zero. Waving our hands? When we wave our hands, we experience something on our hands. It is nothing but air striking on our hands. This is also a result of fluid friction acting on our hands. The fluid friction acts on the opposite direction in which the hand is moving. Swimming? When we are swimming, our hands go inside water and come out. When the ends are moving inside water, they experience resistance against movement. This is the fluid friction coming into action. The water molecules resist the movement of hands. Rowing? When we are rowing, we use the paddle stick to row. There we feel the pressure acting against us due to fluid friction. We invest a lot of physical energy to overcome this resistance. This is an example of fluid friction. Paddling inside river? Paddling is again a similar example to rowing. In paddling we can say rafting or normal paddle boating. The principle is same. We feel the resistance against the movement of paddles. Submarines? When submarines move under the surface of water body, it experiences strong resistance to its flow. This happens because of the fluid friction taking place on the surface of the submarine. Aeroplanes? Aeroplanes experience drag. The drag is opposing force to the movement of air. Excess of fuel is spent to overcome this drag. By making the shape of the aeroplane aerodynamic, the drag force reduces. A ball dropped inside river? When a ball is dropped inside a river, it keeps on flowing down, but after some time it achieves constant velocity. This is the terminal velocity. The fluid friction acts against the motion of the fluid. Paragliding? Paragliding is an application of fluid friction. We take use of fluid friction to navigate from one place to another. Without fluid friction, we would not be able to achieve proper maneuvering. Parachute? Parachute is also an important application of aerodynamic drag. The aerodynamic drag where the fluid friction helps the parachute to slow down, hence ensuring a safe landing. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. scientific calculator, and many more other tools.